Hi everyone, I wanted to make a quick video explaining multiplying radical expressions with binomials. It's not really complicated. It's using tools and things that we used before. So basically distribution and FOIL. It just may seem a little weird because of the radicals, but don't let that scare you. It's still using the same things we've used before. So the first example would be distribution. So remember, we multiply coefficients by coefficients and radicals by radicals. So what I mean by that is my coefficient here would be 1, right? Because there's no coefficient with it. So I'm going to distribute this to both terms, right? So I have square root of 6 times 2. So that's going to give me 2 times square root of 6. Because remember, I multiply coefficients by coefficients, radicals by radicals. It's almost like we have a variable here. It's almost like that this acts as a variable, except it's not a variable, it has an actual value. Alright, so I have 2 times the square root of 6, and then minus. Then I have square root of 6 times 3 square root of 6. So I'm just going to write that like this. Alright, so remember the coefficient here, it would just be 1. So if I multiply 3 times 1, I get 3. The square root of 6 times the square root of 6. It's going to give me the square root of 36, which I know is just going to be 6. So this is technically going to be 2 square root of 6 minus 3 times, and we decided that square root of 6 times square root of 6 gives me square root of 36, or 6. So 3 times 6, which is just 2 square root of 6 minus 18. And that's my answer. So I just distributed to both terms here like I would if I had anything on the outside. The important thing to remember here is coefficients multiply with coefficients and radicals multiply with radicals. Alright, so what if we had one that looks a little bit different? So you do remember how to FOIL. First terms, outer terms, inner terms, and last terms. So here's an example. For F, we have our first terms. O, we have our outer terms, so the ones on the outermost bounds. Inner, we have our innermost terms, so B times C. And then our last terms. So last terms in the binomial, B and D. Alright, so let's try that here. So I'll use a little bit of color since you guys like color. So I have my first terms. It's going to give me 4 times the square root of 3 times square root of 3. So I'll just write that out. Alright. Now I'm going to have my outer terms. So I have my outermost terms, so 4 square root of 3 times my other outermost terms, negative 5 square root of 2. So I'm going to do coefficient times coefficient. So 4 times negative 5 is going to give me negative 20. Square root of 3 times square root of 2 is going to give me square root of 6. Alright, now let's do our inner terms. So I have the innermost terms in my whole problem here. So square root of 2 times square root of 3 is just going to give me positive square root of 6. And then my last terms, which are going to be the last terms in each binomial. So I have square root of 2 times 5 square root of 2. So remember, coefficient times coefficient. So it's like I have a 1 here, right? So 1 times negative 5, negative 5. Square root of 2 times square root of 2. Well, that's going to give me square root of 4, but the square root of 4 is actually 2. Alright, and if we're a little confused on how I got that, I'll just write it here. So square root of 2 times square root of 2, right? My last terms here gives me square root of 4 which I know is actually just 2. All right, now that I have these, let's go ahead and simplify a little bit. So I have 4 square root of 3 times square root of 3. So it's the same thing that happened here. Square root of 3 times square root of 3 is going to give me square root of 9. So when I simplify, I get that it equals 3. So 4 times 3. Because, I'll write it on the side here, square root of 3 times square root of 3 equals square root of 9, and that's just 3. So that's where this 3 came from. So 4 times 3 minus, now here, I'm going to use some of the things I learned in our last lesson. I have minus 20 square root of 6, and then I have plus square root of 6. So remember when I said they act like variables? So we can add these two because they have the same radical. So our coefficient's technically 1 here. So minus 20 square root of 6 plus 1 square root of 6. We don't change the radical. We do change our coefficient. So minus 20 plus 1 is going to give me minus 19 square root of 6. And then minus 5 times 2. So 5 times 2 is 10. So minus 10. All right, now I'm going to simplify further. So I have 4 times 3 gives me 12. Minus 19 square root of 6 minus 10. Okay, now I have 12 minus 10, which is going to give me 2. And then minus 19 square root of 6 is what I'm left with. So this would be my final answer. All right, so it does get a little messier just because of all the radicals in here that you have to multiply and then figure out, you know, if the radicals cancel or if you have to simplify later. But if you just follow the patterns like we've done before, you should be fine with all these problems. If you have any questions, please let me know, and I hope this helps.